The answers. So we'll see the answers for quiz in a bit. So let's get started. So a recap. So what did we study last week? What did we learn about last week? Anyone? Can you unmute and tell me? What did we see last week? Can anyone hear me? Sorry, go ahead.
Files.
Files, correct. So we saw about files processing. We saw about input file, output file, and how to read, write, right? Okay. So last week we did not see the session 7 homework. So here it is. So these folks have done an excellent job in their homework. They've gone beyond what we have expected, and they have done a tremendous job. So great job, guys. So we have published the session 7 homework solution on your class material, and that homework is submitted by Kavin. So Kavin, we have submitted your homework as a reference for everyone to see. So good job. And Pranil, Varsha, Elric, and Likita, great job, guys. Keep it up. Okay. And as far as the last week's homework, session 8 homework goes, so we have Sanvi's homework published as a homework solution on the class material. Very good job, Sanvi. So keep it up. We also have Pavitra, Shri, Varsha, Elric, Shri Abhinaya, Balasubramaniam, who have done an excellent job as well. So good job, folks. Okay. Okay. Before we go to today's session, I think I have one more to tell you. This is it. Okay. So we have. Can you guys see the screen?
Yes.
Okay. So we have triangular talks coming up on December 11th, Saturday from 10 to 11 PST. So this week we are going to talk about how does market research help inform consumer product innovation. So we're going to have Ms. Teresa Cherry from commercial operations, and she's going to be as a guest, and she's going to talk about all the market researches on this consumer product information. So if you are interested, please go ahead and join next week's session and see what the market is all about, right? So you get to understand what is going on the other side of the world. Okay, it's a 1 hour session from 10 to 11. Okay, so the next one on agenda is so today we are going to talk about classes. Okay, we're going to talk about object-oriented programming and classes in particular. So far what we have seen is like we have seen introduction to Python programming. We saw about different data types, collections, and we also saw about multi-dimensional collections. We learned about functions, error handling, and we also saw about files and the input, output, and file processing in last week. And today's session is about classes. So with this, we will be wrapping up this fall semester on Introduction to Data Science. And I think next session is your final exam. Okay, let's get started. So how many of you have heard about object-oriented programming or objects or classes, like just a general terms or such that? So have you, anyone of you heard about it in generic or come across this in a different language you have studied?
I feel like classes would be a way to like organize files.
I'm sorry?
I feel like classes would be a way to organize files from what I've heard.
Okay. So anyone else? Class, objects, object-oriented programming. Nope. Okay. So in general, right? So a programming language, so all type of programming language that we have in market today, we use day in day out, can be classified broadly into like two categories. Okay. So one is procedural programming. The other one is object-oriented programming. What is procedural programming? Is the one that we have seen so far, like what all the examples that we have seen so far in Python is example of procedural programming. So what it means is we just create a procedure which will do something like some actions like calculate BMI, calculate your average, calculate your score. So it's a common practice so that we just write procedures or actions that takes place in a program. So then the data will be just passed to that program and output, you will get an output. Then you want to do something else, you pass that data to another function which will do something for you, like calculate your average. You pass all these data to that program, it will calculate your average and give it back. You want to calculate again, say the total of all averages, you send it to another function that will just create a total and give it back to you. So procedural programs are mostly not object oriented. Like the data is the least priority. Data gets passed from one place to another. So it's not data centric. It's mostly like it's based on the methods or the function. The whole logic of it is based on the functions. You have function one, which has some characteristics. You have function two, which will do something else. You'll have function three, which will do something else. So every function will deal with data, but the data is not the hero there. The functions, the methods is the hero, and the whole program is structured based on the function. Say example for the we just had one homework, right? What did we have? The example to get that menu item, right? Like your shop who has like what items you have in the shop, just give me the menu item, add, drop. So for all that things, if you remember, you would go first and identify what functions I need, correct? You will just go based on the actions that the program has to take. You would define, okay, function one, okay, I need to add. Function two, I need to subtract. Function three, I need to multiply. So that's how the whole programming structure starts. We do not care about data. Once you define the function, then you tell, okay, this function needs two data elements to add, right? You need two numbers to add. So you then define, okay, function one will get two data as input. Function two will get two data as input, and it will return one data as output. So you just write whole program based on that. So after you finished your program, right? So I come and say, sorry, I gave you the wrong requirements. I gave you the wrong question. I need you to add three data. So what do? Anyone? So we already have a program. That program handles two data. So now I come back and say, oh, sorry, it's requirement change. I'm sorry. I need you to do three addition of three numbers, addition of four numbers, whatever. So what do? You have to go back and change all your programs, correct? So when the data changes, you'll have to change your program accordingly to meet it, right? So this is like one page program or maybe a two-page program. That it's not a big deal. You could go and add data three, data three, data three, right? Imagine you have a whole software written. You have a whole like 1,000 pages of complex program written, dusted, tested, everything is done. Now the business or for some reason some change comes up. Okay. So now you have to add one more data. Adding one more data to 1,000-page programming is not easy, correct? So while adding, you'll also have to make sure you are not breaking something. Your program was working before, now I added a third element, it's failing. So you end up with that, you end up with all those complex scenarios, right? So because the procedural oriented programming is what is called method centric, function based kind of thing. It's nothing wrong, but those are the cons of the procedure oriented programming. Okay. So before this object oriented concept came into picture, procedure is the only way to go, and we all survive with all those softwares. But now people evolve, right? So we evolve with all the outflaws and try to create up with something new or something that will help us solve the problems. This one such case is this object oriented programming. So what is object oriented programming is? here the whole programming logic or the whole structure of programming is centered on an object. Okay, what is an object? Anyone? What in general, like forget about Python, concept, software, everything. What is an object in a plain English statement? Anyone? What is an object?
It is a thing.
Anything, right? Anything and everything is an object. Pen is an object. Computer, an object. You are an object, right? I am an object. Everything or everyone or everything around us is an object. You could classify everything as an object. So the whole concept of it is it it is based on that object. Okay, so what this object can do, cannot do, what are the properties of that object. So once you define that, so you have a whole program written for that. So until and unless that object changes, nothing is going to change. You're not going to change, right? So pen is a pen is a pen. It's going to be the same for any matter, right? It's black in color, it's red in color, it can write, it can draw. So these are the characteristics of an object. So based on keeping this in mind, this whole object-oriented programming is written. So everything is an object, and they find out what is the data point for those objects. Data is nothing but characteristics, right? So data is nothing but characteristics of what do you call the attributes you can tell. Okay, what is the color? What is the make? Who made? When was it manufactured? So all these things are called data points or the attributes of this object. What can this object do, right? So those are all characteristics. Those are all classified as behavior. Okay, it can write, it can draw. Another example is car. If you consider car as an object, so we need to identify two items, two major characteristics for this object. Okay, so take car as an example. So what is the two characteristics? Car, you can tell what color it is, what make, what model, what year. So these things are not going to change for a car, correct? So these things are going to be static for that car. So this defines the car's attributes or the data points. So what can car do? So what is the behavior of the car is? It can brake, it can accelerate. So those are the two things, right? It brakes, it stops, it accelerates, it moves. So these two are the behavior of the car. Another example is like, let's take an animal as an example, like a dog. So what is an attribute of the dog? What is the data points of the dog? So its weight, it weighs 300 pounds, its height is 43 inches, it can run at a speed of 40 miles per hour. So those are the data points, those are the attributes. What can this object, what can this dog as an object can do, right? What is its behavior? It can eat, it can run, it can attack, right? So those are the behaviors. So all the objects is what they classify and create. Okay, for this object, this is this attribute, this is the data, and this is the behavior. Okay, so what it comes is, so what object-oriented programming tells us is, it's a technique in a short form to tell, like, it represents everything as data and methods. So it considers everything as objects and represents everything as data, methods. Data is what defines as an object. So what is these characteristics? What are the attributes of that object? So those are all data. What it can do, what is the behavior of the object? They are all methods. So they classify everything like this. So now what happens is, so every problem is now converted to as like a objects. You identify all the objects in that program. Then you define what the data is for that program. You define what that object do for that. So now everything is a separate object. Okay, so the whole program they divide like that. And now whatever you want to do, you either use the data of that object or use the method of that object and do. So that way, even when the program goes larger and larger, the object characteristics or the methods is not going to change. So you just work on top of it. Okay. Another example. Okay, let's take this example of calculator. Okay, so calculator is an object. So what is the data points for calculator? So date attributes is the technical word, or you can call it data too. So what can you tell about this calculator? The calculator color, it's gray, its size is medium, it has 16 buttons. So these are the data of these objects. Okay. So far when I explained, right? So you could tell what the data is. It's all referred in nouns, right? So what is it? The what describes the data, correct? So everything will be in a noun, like it's gray color, it's medium, its button has 16 things. So these are all data. So what is behavior is verbs, right? Verb as in it's like an action, correct? So what the calculator can do as an action, like what is a behavior, what is a method, what is the characteristics. So whatever phrase you use, so what exactly can the calculator do? They are the methods. What can the calculator do? It can sum, it can subtract, it can multiply, it can divide. So these are the four behaviors for this particular calculator. So now when you consider calculator as an object, you have defined these things. You have defined the data, you have defined the behavior. Any questions so far about objects? What is an object? Forget about the whole concept, but what is an object and what are the two characteristics an object can represent? Any questions?
No.
Okay, cool. So another example of object is human, right? Like I said, you and me, we are all objects too, right? So what are the data points for humans, right? You can tell what color, race, ethnicity, all those form questions. Or in general, like what height, what weight, what else? So height, weight, something like that. So they are all data, right? So what are the behaviors? So what can a human do? A human can talk, listen, see, he can run, walk, jump. So those verbs, those behaviors are all methods. So when you define a human as an object, this is how you define the data and the behavior, or attributes and methods. Okay. So now we have seen, or we understood an object. Okay. Okay. So before we go to class, we'll get one step back. So why object-oriented programming? So I think I've told you before, like in the first slide too. So, but why is we could code faster? Like there's a code opportunity for code reusability. Since you are like, once you define an object and you set the methods and you create the data for it, you could use it anywhere. Like you create a class for, say you create a class for pen, right? So it's someplace else. If you want to use it, you could simply use that. You could implement, or you could use that class. For now, you just call the word use. Okay, so you could use that class and you could continue. So that means there's a lot of opportunity for code reusability, because we are not changing, or we are not changing the characteristics. We define them and then we use them in our program. It's very easy to maintain because every class, it's like very neat. It's like segregated away from all our programming logic. So it's like everything happens behind the screen. So we are not touching it. The data does not get thrown from one place to other. So it's very easy to debug. So we know which program has access to this particular, which object has access to this particular class. And so we could identify who has changed the data. Okay, because data is very closed, private, it's protected, it's encapsulated, I would say. So you could easily tell like how where exactly it's gone wrong. So for all these features, for all the downfalls that we had on the procedural programming, those are all pluses in this object-oriented programming. Okay. So what was I going to tell? A class. Okay, we saw about object, we saw about class. Okay. So what is class? So now we have seen what an object is, right? Everything is an object. Object is just an instance of a class. Okay, what is instance of a class is? Consider like this. So everything is an object, and every object is a member of a class. So how do you visualize it? Say, for example, as the same example I said, right? Me, you and I said I'm an object, right? But we all belong to one common class. What is it? We're all humans, right? So we all can be classified into one classification, right? So that is what it is. That is what the class is. Okay. So if you take dog, cow, sheep, tiger, so all these are all objects, but they are also a member of a class. What member it is? They all belongs to the class animals. Correct. So the hierarchy or the group which you could classify and group together, that is a class. Okay. So we are doing a bottom up approach. So I defined what object is, and then I'm telling, okay, if you group all of them together, that is a class. Okay. So if you see it in the other way, so class is nothing but a code that specifies the data attributes and methods for a particular type of object. So you tell human class. Okay. Human class is nothing but if all humans can, has a color, has a height, has a weight. So these are all the data for humans, and all humans can run, walk, see, hear, listen, talk, and all that stuff. If you take the class as example as animal class, right? So now I'm telling animal class. So animal class has two attributes. What is it? Data. What is the data attributes? The animal's weight, height, speed, and all that stuff. Animal's behavior is they can eat, they can attack, they can run. So this is like a blueprint. Okay. So instead of defining this class every time for like you write one time for like dog, then you repeat it for lion, again repeat it for tiger. So instead of doing this for every single object, we are going to do it at the high level. We are going to do it at the class level. We are going to tell the class name is animal. So any animal, you name any animal in the world, these are the common attributes that belongs to this animal. Okay. So it's like a blueprint. So imagine you have this cookie cutters, right? So what does cookie cutter do? Whatever shape you take, that's what the cookie cutter shape is going to come out of. Correct? So class is like a cookie cutter. It's just a blueprint. You cannot eat a cookie cutter. You cannot do anything with a cookie cutter, but it defines you the shape and what it's going to do at a high level. Then every cookie that you create is an object. Understood? So you use that blueprint like a home. Take an example of this whole house, right? So it's a blueprint, right? It by with the blueprint, I cannot go in and live. I cannot go cook into the kitchen's blueprint, right? But it just defines me. Okay, this house is going to be like this. It's going to have 4 bedrooms, one kitchen, one living room, blah blah blah. Okay, so it gives you like a blueprint of it. When you go look into animal class, you can tell. Okay, so animal class can handle this data and this has these many methods. So on top of it, you can create an object. So I'm going to create a dog as a class, dog as an object, but that belongs to an animal class. So that's the hierarchy of classes versus objects. Okay. So technically, if you want to hear the term, so class is a code that specifies the data attributes and methods of a particular type of object. It can be any object. The moment you generalize those objects and create a data and attributes, that's called a class. Any questions? Do you guys understand what the class is?
Yes.
Cool. Okay. So every time you create an object from a class, that's called as an instance. In technical terms, the creation process or like it's called instantiating an object. Okay. So you create the class from which the objects are instantiated. That's a word of like one-to-one word. Okay. I think I said this too, right? So another way of thinking about the difference between a class and an object is to think of the difference between a cookie cutter and a cookie. The cookie cutter it's not a cookie, right? But it describes a cookie. Okay. So cookie cutter, it describes a cookie, so that is a class. So it tells what are the shape, size, what all the stuff, right? So the cookie cutter is the class. And all the objects, so all the cookies that is created from that cookie cutter is the objects. Okay. So when the program is running, it can use many objects of a specific type as needed. Each object that is created from a class is called an instance of the class. So you just define a class there, And based on your need, you can create how many number of objects you want to do with it. You could do with it. And every object is an instance of the class. So you just create dog, you just create tiger, you just do whatever you want to do. So but everything is an instance of the class. Another example for object is, like I said, so my name is Nadiya, right? So, and I am an instance or object of class human. Okay, not man, I'll call it human. So when we say human being, man or woman, we just mean a kind, a general kind. Okay, so you, your friend, me, everyone are all objects of this classes. So we have a physical existence. So we all exist, right? So I live here. So Nadiya is an actual object, correct? But when I say human, that's nothing like human. You don't see a human as a human, right? So it's kind of a logical definition. So the logical definition, the blueprint, so all these words are what classes and the real object that we use from the class. So once you define a class, it's nothing. When you just define a class and run a program, you're not going to get any output or anything. It's just telling like, hey, this is a definition of this class. This is a definition of human. This is how a car is. This is how an animal is. So Python will learn it. It will just read through it. That's it. The program will not run because we have not instantiated. We have not used it, right? So when I come into picture, so now I, as an object, I exist. I can talk. I can do everything. So now I fall under the class of human, but I do my own activity. So now I am an object. Okay. So we have seen what is an object, what is a class. So in Python, how do you create a class? Okay. So how do you define a class? There is a syntax for everything, right? So though we talk technically, at the end, when you and Python will have to have a common language to interact, right? The syntax to define a class is class and your class name. So here we are using the example of coin. So when you, okay, so class and it's, we're telling class is a coin, and whatever you write inside it, that all those code belongs to that class coin code. Okay. So naming convention for coin or for the class. So all the naming rules that we have for variables applies to class. Okay, it cannot start with a number. It can be like it can have lowercase, uppercase. It can do anything, but we always start the class name with a capital. Like if you see right in the coin, we start with the capital C. It's not, if even if you do a small c, the program is not going to fail on you, but the programming standards or like the convention is to use a capital first letter as a capital. So that way we know we are talking about a class here. So down the in the line, if you use some other names and you see a coin with a C, even without referring the code above, you could tell that is a class we are talking about. So that's some unwritten rules to follow. Okay. So this helps us to easily distinguish the names from variable names when reading code. So if there is like a class coin and there's a variable coin, the one way to easily differentiate is with that capital letters. So how do you create an object? So this is the syntax. So my coin is an object. So now I have created one coin called my coin. You equal to coin of. So this syntax now says now this object is created and this object will have access to everything underneath. So class coin will have what? It will have data. It will have methods, right? So class coin will have coin, like what is the data? Coin is shape round. It has two sides, right? Head and tails. Basically, head and tails is what coins is for, right? So we toss. So we can say we have two data there, and action is toss. You just toss the coin and you get either a head or a tail. So the action or the method is toss. So now once you create this object from this coin class, this my coin, this my coin, my underscore coin has access to all data and the methods in the class. So this my coin is what is going to do whatever you want to do. So this is what will refer the program and execute all those steps. So here the class is just a definition. This is the instantiation. From now on, this my underscore coin can do anything or whatever we write the program to do. Okay. Okay. Clear so far?
Yeah.
Thank you. Let me see if I have to cover anything. Okay, so we saw about the class definition. So now we have something called as init method. Okay, so here when this statement got executed, this my coin underscore equal to coin, when this get executed, there is some action behind it, correct? So once this happens in these statement one, statement two, so what is that is what we are going to see now. Okay. So when this object gets instantiated, something has to happen, right? You have to set up the default by so you have to set something by default. You'll have to do some initialization. So all those things. So you have to define methods inside of it. Correct. So that's what these methods are. So in Python, all the classes will have the special method called init method. Okay. So if you see this init method, right, it's double underscore. Okay, underscore underscore init underscore underscore. That's how it is defined. Okay. So it will be like this when you write. I just wanted to show with a space so that you guys can distinguish. Okay. So it's a double underscore init and a double underscore. So what happens is like whatever statement you write under this method, method is nothing but a function. Okay. So function or method, it's the same. So for whatever we have seen functions, right? So they are the same. When you get into this object, oops, or this thing from now onwards, all the functions will be referred as methods. Okay, so methods and functions are the same, they are almost the same. Okay, so when you should have a method inside of it, right? So all the class should have a method, correct? So either eat, write, or whatever, it has to have a method. So but there is this special method called init method. So this is called as initializer method. So what it does is it initializes the object's data attributes. So what is a data attribute? So we saw when you take an example as an animal class, right? So what is the data attributes there? Height, weight, right? So you have to initialize it, right? So if you have to initialize it, so this method is what will do it for you. Okay. So the name of the method starts with 2 underscore characters followed by the word init and then 2 more underscore characters. Okay. So this gets executed. As soon as you call this my coin equal to coin, if this will have a init method. As soon as this is done, the init method will get executed automatically. You don't have to call it. For every other method, you have to explicitly tell the method, right? You have to call that function explicitly. But for init method, it will automatically execute. It's kind of like a default statement. So you whatever you want to default to, whatever you want to set it as default at the start of the program, you do it in this init method. So this example, if you see the class coin, right? So my first method here is define init underscore underscore init self. Okay, I'll talk about this self in a bit, but imagine this is the first thing. I say self dot side up is equal to heads. So what I am doing is a coin can have 2 sides, correct? So the side up can be a head or a tail, but by default I'm setting it as heads. Okay. Similarly, for if you take example as the human class, by default I can set some name to the class, right? I can set some default weight or anything. So whatever, if I want to set any default, I use this. Okay. So what is the self parameter, right? So every data attribute we talk about. So any data attribute or this object attributes that we are talking about, it has to have something, like it has to tell or on top of what it's acting on, correct? So it has to have a reference for it to tell which upon which it's acting upon, right? But in this case, it's not acting on any other object, correct? It's just creating its own instance. It's just initializing itself. So this self word comes into picture there. Okay, so it's telling that Python that hey, this method is just operating on its own on itself, And so self dot side up is equal to heads means we are just talking about this class called. So this class is now instantiated with this objects with this side up data as heads. So that's where this self comes into picture. Okay, because we are not initializing another object or we are not passing any other argument. This is on its own on the class itself. So we are using this term self. So here is one full fine example of a class person, right? So we said human, right? So let's say it's a class person, okay? So define. So the first class in it is define double underscore init, and I'm doing a self comma fn comma ln comma a. So it's nothing but like a first name, last name, and age. Okay. So what it is doing is, in this case, I did not pass any parameters. Correct. Here I just said self, meaning no parameter got passed. This class got instantiated with the hard coded value called heads. Okay. But that's not always the case, right? We don't hard code it. When you hard code it, you are just restricting yourself, right? So what if you want to initialize the values passed by the user? You get inputs, right? You ask the user what's your name, you ask the user what's your age, you ask the user what's your height, correct? So now you want to initialize those values for this class. So how do you do that? Is this. So define init self. Again, we are talking about self because we are just initializing this class object only. We are not talking about any other objects. So this self will stay as it is, followed by first name, last name, and age. So these three parameters. So whenever you call this class, whenever you instantiate an object, you will also pass first name, last name, and age as a parameter. So when you do that, whatever the value is getting passed, that will get assigned to this objects, to this data. Okay, so first name will be fn, last name will be ln, and age will be a. So whatever this parameter comes in, I am just assigning the values. So this example is, if you have hard coded values to initialize, you go this route. If you pass the values from the user, like you get that user input, right? That input statements, and you get the values, you pass it here. How do you call this? Here. So here I'm calling the class person. So P1, right? So this is my object. So I am creating an object called P1, which is nothing but an instance of the class person. So when the moment you tell P1 equal to person colon the parenthesis, it means you are calling this class first. You are creating an instance of this class. Okay. But we are, in this case, we are passing the parameters. We are telling the person name is first name is Sarah, last name is Davis, and the age 21. So now what happens? This P1 gets all these values, first name, last name, age, initialized. Okay. So the first name will be for the object P1, the first name is Sarah, last name is David, and the age is 21. So now if you do a display, right? What is a display? Display is the another method in the program. Okay. So remember, the init method is not called. You did not explicitly call the init method. The moment you called the class, the init method got executed automatically. But there's another method inside the class called display, right? So what it's doing is it's displaying its own data. Self means it's displaying its own data. So what it's printing, same thing. Whatever you want to print, you are printing hi, self dot first name, last name, and your ages. So you're just having this data printed. So this is the data. You're having this method, this display function is printing those data. So the moment you call p1.display, it displays the first name. What is first name in this case? Sarah. Last name is Davis, and the age is 21. So that gets printed. So now for the same class person, we are creating a second object, which is nothing but P2. Okay. So all you do is you're again calling the same class person. Now we are telling it's John, Henry, and 25. So all the data points, all the functions, whatever you want to use, you are not rewriting, right? You just have it. You just have the blueprint here. You just have the definitions here and you pass the values. So now you tell, now P2, this P2 is nothing but a second object of a person. And for this P2 object, first name is John, last name is Henry, and age is 25. Now, if you ask this P2 to display, what is going to do? It's going to display, hi, John, Henry, your age is 25. Because now we are talking about this object, P2. Clear? Any questions? Understood?
No. Yeah.
Okay. So who's that talking? Is that Prince?
No. Abhishek.
Abhishek. Okay. Okay. Let me open the collab and let's execute this code so we could see what's going on. Okay, can you guys see the screen? Okay, how to? Okay. Okay, so let's just execute that code so we see how a class exists. Okay. I'm telling the classes person. So the first method for the classes, it should have this init method by default. Okay. So this is a method. Okay. So this is the method. This is the class. This is the default init method. Okay. So what I'm telling is now as a class, as a person, what do a person has? The person has first name, last name, age. What else can a name person have? Height. Okay. So these are the data that I'm gonna use for this class person. Okay. So now, like I said, all these characteristics, right? All these things has to act upon something. In this case, we are just still talking about this class person or whichever object it's trying to do. Upon that, we are going to create this variables, right? So we use this word self. So when in so in this case, so when P1 called person, the self referred to this object P1. When P2, when we created this object P2, the self referred to this P2. Again, if you create one more P3, the moment an object is calling, it refers to that object. That's the key for that self. Instead of hard coding as like P1 dot, then again next time you do P2 dot, you're just telling self. So whichever object is calling, for that I'm going to create a first name, I'm going to create a last name, I'm going to create an age, and I'm going to create a height. Okay. So first example, I'll just show like a hard-coded value. Okay, I'm gonna say I am Nadiya. My last name is J, and my age is sweet 18, and my height is what? 5.6. However you differentiate it. Okay. So this is my characteristics. So now I'm hard coding it. Okay, I'm just doing it. So then I have a second function. So I have this data points, right? I have this data defined in a class. What do I want to do? I just want to do something. I just want to do some print statements. Okay. Print hello, like our favorite print hello, right? So even this print hello, it needs to be acted upon some object, right? So since I am defining this in a class, I'm again giving it as self. So whichever object calls, you have it. You enjoy with this function. Okay. So what I'm going to tell is print hi, hello there. Okay. Then what do? You could do here. So this first name, right? So this whole thing isn't variable in our case here. Okay. So it's gonna tell my first name, my last name. Okay. Then in the next, I'm gonna tell our ages. So what's my age? Self dot age and print. Your height is self dot height. Okay, so that's it. So we have defined a class. Inside of the class, we have defined what all the data it has, like what all the, so these are the data attributes, right? So we have defined the data attributes in our init class. Then we have a method for hello. Okay, so this is the definition of a class. Okay, so it can be anything. So whatever class we are writing, the format is same. It will have a init class, then whatever you want the class to do. Okay. So now, if you run this code, finished. The code executed. So Python has read this definition. Okay, I read, but it not execute anything because you're not using it. You have just defined it. Okay, so you have to build, right? You have to build a house on top of it. You have to create a class person. So that's where you do, what do you call? We'll call person P1. Okay, so P1 is an object of class person. Okay, so this is called instant, what is it called? What is it called? Okay, someone is telling, someone right. So it's an instance, right? So when you call, you give an object name. I'm calling it P1, and I'm calling the class person. Okay, since since the class person does not have any what do you call it? Does not have any arguments to pass, I'm just keeping it empty. Okay, no arguments. So I'm just not passing anything. Okay, now, so now what happens? This class P1 has access to everything, all the data and the methods. This object has access to all the data and objects. So now I can do anything with it. So now I'm telling P1 dot print hello, right? So since it's a method, you just call like that. So you tell P1 dot print hello. So now let's execute. Okay, so now what happened? Whatever, since there is no argument, so this variables got initialized from here. And when this function that was called print hello was called, it just prints the first name, last name, and all the ages. Okay. So now let's see, let's rewrite the same example saying with an argument. Okay, so now I have this class person, but I want to get a variables. Okay, so I'm going to tell pass me the first name, last name, age, and HGT, and I'll just call H and A. Okay, to differentiate. Okay, so pass me first name, last name, A and H when you call the object. So now what you have to do is you have to pass. You have to now tell, what do you have to tell? You have to now tell person. So whatever I gave here, I'll have to pass here. So I'll have to tell Nadiya here. Sorry. So here it's no longer first name, right? So whatever the argument is coming inside of this parameters, that is what will get assigned to these variables, right? So here last goes here. Similarly, like in the function we saw, right? On passing arguments in a function, it's the same concept. you get an argument here and you pass it here, you assign the value here. So now A is self.age and H is self.height. So now you have it here. And when you create the object, that is where you are going to tell your name. So it's like my first name is Nadiya, last name is Yes, and what is next? Age. My age is 18 and my height is 5'9". So you just tell something here. Okay, so now even now if you do, you get the same data. So in this case, what happens? So whatever the parameter you are passing is what initializing in this init method, and this function prints it. Okay. So you could also do this. Okay, like so here I'm passing a value again, hard coding, right? So in real world, what would you do? You would get it as a print statements, right? You would get this values as an user input and then you just pass it, right? So you can simply say input of enter name. You could do all these things. So whatever we have seen, right? So first is equal to input enter. You just do this, all this, and then you just pass it to this person object that gets created. Okay, I'm not going to do that because we have seen those input statements a lot, but it's a concept. Okay, so you create it either here or you create it as an argument. So you could create one more object too, right? Like we saw in the PPT. So person of first name is Jack, last name is D, age is 78, and height is 5'11". So now this person D is created. Now you have to call this object and have this function called print hello. See, case is wrong. So here, so my first object is this, my second object is this. So now you have two objects and you could handle it in your code however you want to. Any questions so far? Understand?
No questions.
Okay. Cool. What is next? Okay. So now I'll take this example. I'll tell you something. So when I was explaining before, right, I was talking about a term called what was it? Encapsulation and all that stuff. So what does that really mean is whether you want to allow these objects to be accessed from outside or not. Okay. So that is what you could do. So now once you have these objects created, you have this data created, you have this method created. Okay. So in object oriented programming, there is a concept where you could tell whether this can be accessed by another. It can be accessed by another programmer or it can be modified or not. Okay. So here, right? So whatever we have written this print hello, right? So you could modify this object, correct? You just come here, you just take it, you can reset it, you can modify it. So these are all public attributes. So once you create an object, all this is public. So anyone who has access to this class can use it. Okay. But there is one more called protected. So what is protected is it prevents access from the outside. Okay. So for example, it cannot if you create this one, right? So if you say, which one can I say? Okay, let's take this as an example. Okay, so here, if you see, this class is there, right? So this class person, you could instantiate outside of it. And you can modify the values as well. You can now come here and change what the name is, first name or last name is. So if you add a variable, so if you add an underscore before the variable, then that means it's protected. Okay, so for example, if I say age, if I do an underscore here, okay, if I do an underscore here, now this becomes protected. Okay, so what does that mean is it cannot be accessed from the outside other than this particular instance of the class. So it's not conceptually you're not achieving much because you cannot even access the class without an object, right? So in that case, so this one like self or age or self dot age is the same. So it's not gonna make much sense out of it. But there is another one called private. Okay, so what is private is, so you make it with a double underscore. Okay, so you now this is a private attribute. So what does private mean is, this height is a variable that belongs to this class person. You cannot change it. So you cannot modify a value by assigning it from the outside. Any object outside of it or anything cannot be changed. It's kind of like a set variable, like height is 15. That's it. You cannot change it. So this is going to be a static across. Every time this class is created, this value is going to change as it is. You cannot change. If you attempt to change this private attributes outside, like if you try to assign a value or if you try to change this height value from here, we will get an error. Okay, so public, any object which has access to it can create it. So this protected, it can create. This is more useful when we talk about the inheritances, like a class created from another class, another class created from another class, right? So when we study about subclasses, so you'll understand more about how this protected comes into place. But for our structure so far, what we have seen, this does not make much difference. So any object of this class can change it. Okay, but an object of a subclass cannot change it. That we will see it in the later class. So what?
Oh, sorry. So can another class change it for protected?
Another class.
So like there's another class named human.
It cannot.
Saying it cannot, or it's only for that class only.
That class, yes. All these attributes are for that class only. So whether an object can change or cannot change is the question. So now when you create this P1, P2 object, right? So can this object change or not? That's a concept.
Okay, so even for public. Okay.
A class can be changed only by an object, right? Another class cannot come and access this class, correct?
Oh, okay.
Okay, you have to have an object to initialize, to access, to modify anything. You need to create an object of this class. Okay, so anything outside of it cannot touch it. Any object.
Okay.
Yeah. So this is private. So only within this class. So if there's any functions here within this class, you can change it. Like you can change height as a 15 here, and like as part of your own programming, you could change it in the bottom of your programming. But outside of this class, this 15 cannot be changed. It's static. So that's the private object. Okay. And so now we saw about this. Okay, where is it? Yes, will the collab be posted? Yeah, collab will be posted. Yes. Yeah, that was a question on chat. Okay. So we saw about class, we saw about init method, and we saw about the example. And So similar to this init method. So this init method is nothing but the initializer method, right? It initializes the variables. So similar to that, we have one more method in Python, which is called as the str method. Okay. So what does this method does? It's a string method. Okay. It's called the string method. So what does the string method does is it will just display a message that indicates an object's state, right? So every time you create an object, you have something going on, right? Sorry. So here, right? So you have initialized name, whatever the age is, what the display is. So it has initialized, right? So if you want to tell what the current, if you want to tell, if you want to print what the current state of the object is. So what is the value there currently, right? So for example, if you have a bank account program, okay, so you have the data as balance, right? So every time you are going to access it, you are going to change. When you call a withdraw function, what's going to happen? The amount is going to come down. Whenever you deposit money into your bank, the amount will go up. When you pay something, pay your bills, it's going to come down. So that balance value is going to get changed, correct? In your program, depending on who the user is, what they are doing, the value for the balance will change. So at any point of time, say in your program, you want to show the balance. Just call that balance method. You just want to call it and they want to see what the current balance is. Like how you go to ATM, you just swipe and see what your balance is, right? So similarly, you can use this string, str method to indicate what the current state of the object is. So in our example, you just define this method called define string self. You just write it and write a comment whatever you want to print. So in my case, I'm telling the balance is self.balance. So what is balance? Balance is nothing but a variable, right? I'm just printing the balance here. So once you have this method defined in your program, you can call this method at any point. All you have to do is just call the string method. You just call str underscore str. So what happens is it will just print the balance. So by default, Python has given you two inbuilt methods. So one is the initializer method, which will variables for you automatically without you having to call it. And the string method lets you say what the default messages you want to show or how do you want to display the current state of the variables. Then all you have to do is just call it. There is no arguments, there is no nothing. You just call it, and whatever the object you are calling it upon, the statement will get executed. Okay. And we saw about str method. So we've already talked about instances, right? So every instance of the class has its own data attributes, right? So P1 has first name, last name, age. Similarly, when you create P2 has its own first name, last name, age. So every time an object is created, it has its own set of data attributes. Okay. Okay, so we saw about this. So there is two more methods that is there in Python. So we saw about initializer method. We saw string setting method, right? There's two more methods that is there in Python. Okay, so what it is all this data is there, right? So whatever first name, last name, age you have, right? So by default, as a programming practice, you just have to create two default methods. So what is it is? So they are called as accessor methods. So what they are telling us? So you have a class. So inside of class, by default, you have the init method. You will have the init method. Oh, nice. You will have the string method. Okay, and you also have to have accessor methods and mutator methods by default. Okay, so class will have data, right? It has its own data. So it's like variable 1, variable 2. So you define the class, and these are all the methods a class should contain. So we talked about these variables, right? So we talked about init, we talked about string. We are going to talk about accessor and mutators. What is this accessor and mutator is? By the name itself, you could tell, right? So accessor method lets you access these variables. Mutator method lets you modify these variables. So you create a method to do that. So in accessor method, you create or you define a code such a way that it just fetches the value of these variables. So mutator method, it will allow you to change the value of this variable. So why do you do that is by doing so, you are just hiding this data outside of it. You are not changing, you are not showing the actual, you're not exposing the actual variables or the values outside of it. You are just using these methods to do that. Okay. So what happens is this one, whenever you call the accessor method, it returns the value of the class's attribute. Okay. But it will not allow you to change. It will just give back the value. It's kind of like a return statement or a fetch statement, okay, or a get statement. Okay. So you can consider these are all the get statements or get methods. So the moment you do this, all it does is it will just get you the values for this variable. So what does mutator method do is these are called as set statements or set methods. Okay, so what it does is you can use this function to set values for this variable. Say you call this particular function and then assign values to this variable. So that way, what happens? We are actually hiding this data outside from the outside. We are not exposing the whole data. We are giving them a two main. We are giving the programs two dedicated methods to either get the values or set the values. Okay. So what it does is like, so when a program has to change a value of this class, change a value of this object, it has to call this mutator method and pass the value as an argument and then change it. So that way, so we have control over the code. So we could easily track back which function call, which mutator method calls this variable. So when troubleshooting, we always know it's like you cannot define it. It's not happening randomly somewhere. You just look for the mutated methods and see where exactly the value is getting changed. And say, for example, there is a program, right? You don't want the users to change anything. All they need is like to know what the values are. You just give them access only through this accessor methods. You just define them. You don't define the mutator. You call it private. So only accessor method will be exposed. So in that case, all they can do is get the values but of the objects of the current variables, but cannot change it. So these are all, these are the two other methods that you have to have. So these are also called as getters and setters. So it's easy to tell, right? So get methods, getters is easy, setters is easy. So accessor methods are also called as getters. Mutator methods are also called as setters. Accessor methods allows you to get the values of these variables without changing it. Okay, the mutated method allows you to change the values. Okay, but there is a control of who can do and who cannot do. Okay, and passing objects as arguments. I think we have already seen it, right? So how to pass objects as an arguments, we have seen it. Then what else? So then comes this UML diagram. So we'll talk about this UML diagram. So what is UML diagram is? So this is called as a unified modeling language. Okay. So when you define a class, so when you get a program, okay, someone comes and tells you, hey, I want you to do so and so, so and so, so and so. So you need to start somewhere, correct? So you need to know what your classes are and what the data of the classes are and what the methods are. So remember at the very beginning, we started with that, right? Pen, we said pen is a class. So what are the data for pen? It's black, it's thin and all that. What methods of the pen are? It can write, it can draw. So those are the methods, right? So when you design it, like before even you start your coding, you create something called an UML diagram at the design phase of it. You just sit down and think what you need, right? So what you need is illustrated using this unified modeling language. So this is the structure, right? So the class name goes here, okay? At the very first column or row, the class name goes. You just tell what the class is. Beneath it, you tell what the data attributes are. You just list it, okay? And beneath it, you list the methods. That's it. So you just, say if you say an example of coin class, you just tell there is only one data, right? Which side it's up. So side up. And what is the methods? There's the initializing method. There is a toss method, which lets you toss. And there's a get method, right? So what does get method do? It will get you what the data is, what the current side is. So these are the three methods I'm going to use for this coin, and this is the data. So you just pictorially represent a class using this UML diagram. So once you have that, then you can have your developers, right? Like 5 people, 6 people, whoever goes in. So now you have an understanding. Like now you define every class like that. You could tell by seeing at the picture if a class is missing something or not. So, example, this coin class is here. There's another class which is going to some way interact with this class. So now you can identify if you need more objects or if you need more methods, what you want to do. Okay. So even before you start coding, you write this UML diagram. So here's another example for cell phone. So for cell phone, what is the data? So manufacturer, model, retail price. So all these three is the data for cell phone, and these are all the methods for the cell phone. So now you understand the design of it, right? Without having to go to the code and check how it looks, you can check it here. So that's the unified modeling language. Modeling meaning you just model the class, right? So modeling language. So the top section is where your class name goes. The middle section is the data attributes, and the bottom section tells you what are the methods of the class. Okay. So when developing an object-oriented program, so like I said, the very first task is to identify the class you need to create. Okay. Say, for example, alarm, like a clock. So clock is your use case. Okay. So then what you do? The class name is going to be clock. So what are the data points for the class? Hours, current time, right? Current time, current zone, current hour, current minute, current second. And does it have an alarm on or off? What is it? And what time the alarm is set? So all these things are the data attributes of the clock. Correct. So what all class can do? What all the functions I'm going to give for the clock, right? I'm going to have one initializing method that will just set the current time is like, what's the current time now? 11. What is the current time, current minute, current second? It just sets up that, and it also tell me what alarm it is and all that stuff, right? So what functions I'm going to give? I'm going to give, like I said, the initializing method. Then I'm going to say, get me the current time, right? Get me the current time. Or I can also have set time. If my time is wrong and you want programmatically set it, you can have a setter program to set it. So you just have all it. So you identify all the nouns, which is a potential class, right? You identify all of it and then you just display it here. So that's how you design the class before you start coding. Any question on the UML? Okay, so it's nothing but a graphical representation. Okay. Okay. Encapsulation, I think I've touched, but let's go one more time. So what is encapsulation is? It just by keeping your object as private inside a class so that other objects don't have direct access to this. So instead, you will have to have a public function to actually use it, right? So the object can actually maintain its own state via methods, and no other class can touch it unless explicitly allowed. If you want to communicate with the object, you should use the method provided. What is it? The getters and setters. You have to call that getter or setter method to actually change it. Otherwise, you are not allowing it to change it. So this concept of encapsulation, which is not there in procedural programming, but we have it in object oriented. You could hide the object and not expose it and have a defined methods to modify it. So there is another thing called data abstraction in the object oriented programming. What is data abstraction? Generally, what is abstraction? Abstraction means hiding, right? Hiding as in, say for example, you take your phone, okay? You dial a number, the ring goes and you talk to that person. What happens behind it? We don't know, right? We never care. We know you hear a dialing tone and then a ringing tone and then you just start talking. So that's exactly is data abstraction. For the end user, he does not have to know how a phone works, how a phone connects from here to a wireless tower and from there to another tower. You don't have, he does not have to do, he does not have to know all the mechanisms behind it, correct? So you open a phone, you just press the number, that's all the user has to know. Everything else that happens behind it, behind that is hidden. So that's a data abstraction, like a coffee machine, right? You go, just press a button and you hear all the weird sounds going behind the machine, and then you have your cup of coffee, right, coming to the spout. So that's all the user has to know. So you hide all the underlying mechanisms, okay, and just expose what is needed for the users. So that's the data abstraction concept in OOPS. So this is just a term, you cannot actually see it in programming, but this is what's happening behind it. You have a lot of classes, you have a structured program or a large complex program going on, but for the user, he just have to know what exactly he's going to do with it. He just has to have to know what it does. The user does not have to know how it works. Okay. So next we are going to talk about inheritance, but before we do so, I think we'll go for a short break. What's the time now? It's
11:04.
11:04. Okay, we'll be back in 11:10.
Okay.
Okay, see you in 5.
Yeah. Yeah, I'm back.
All right, thank you. Okay, so let's continue with this inheritance and then go to quiz, okay? So far we have seen about the objects, the classes, and what a class contains and what methods a class contains, right? So that's the high level of, like, what do you call, high level layout of what a class can look like and what you can do with it. Okay, so I'll define a couple more what do you call, technical terms of this, and then we'll go and look into a real program and explain you for a little bit. Okay. So with respect to that, so the next concept of OOPS that we are going to talk about is inheritance. Can you guys see my screen?
Yes.
Okay. So inheritance. Okay. So what is inheritance is in real life example of, like, in real, like in English words, right? So what is inheritance? We inherit something from our parents, right? So the characteristics that we have on our own, there are some characteristics that we have on our own, plus we have something that we have already obtained from our parents. The parents, they have their own traits of their own, but still they have some characteristics from their parents. That's our grandparents. So similarly, a class, if you consider, right? So a class has its own methods or like methods and data, correct? And there can be another class of it which has all the characteristics of that original class plus some extra. Okay, let me rephrase it. So let's take this example. Okay, so it's animal class, right? We saw about animal class. We said everything is an object and everything can be classified as a class. So in this example, we said animal is a class, dog is an object. But dog in itself can be another class, right? Because dog has all the characteristics of the animal class. The height, the weight, the what is it? The speed, the data is there. The methods, it can draw, it can walk, it can run, it can make sound. So everything is there. But the dog can has another extra feature called it can be a pet. Correct? So that pet is a peculiar function for the dog. So in that case, what happens is, so dog will be an extension of animal class, but with an additional methods and data of its own. So that's how inheritance work. For example, right? So insect, let's say if you consider example of insect, so every insect has a various characteristics. Okay, but so that can be a higher level class. Then you consider grasshopper, right? So grasshopper will have all the general characteristics of this insect class, but they can also have an additional ability of jumping, right? So this jumping character, this data will be an extra characteristic. So that means this dog class inherits animal class, plus it has its own objects and methods on its own. Okay, so this inheritance is sometimes called as is the relationship. What is it? This dog class is a animal class, right? So this dog class is a member of an animal class. This cat is an animal, right? So when there is an is a relationship, there is an inheritance in place. Okay, so you can call a cow is an animal, cat is an animal, dog is an animal. So animal is a class and dog, cat and cow can be a class in itself. Similarly for car, right? So car is a vehicle, correct? So vehicle is the parent class and car can be the subclass. Okay, because everything is vehicle, right? So vehicle can have one or more classes underneath it, right? So it can be a car, it can be a truck, it can be a bike, but these are all vehicles. Okay, so this is a relationship. Whenever there is a relationship between objects, you can classify that as parent classes and subclasses. So in our cases, this animal class is called as superclass. Okay, so the class from which all these other classes is derived, it's called superclass. The class that is like a specialized class, right? So in general, dog is an animal class, but it has its own special class. It has its own special attribute. So this is called as subclass. Okay, so this is the animal class is called as the superclass, and these classes are called as subclass or derived classes. Okay, since they are derived from this animal, they call it derived. Okay, so the subclass inherits all the attributes and methods from this superclass. You don't have to rewrite. So in our example here, we had this person program, right? Say class is a person, then I'm defining one more class like man, woman, right? So man is a person, woman is a person, right? So in that case, I don't have to rewrite this display function. This class, the subclass that I'm writing, the subclass man or subclass woman can use these functions without having to rewrite. I just have to point it and use it. So that's what makes it easier, correct? So all the base class code, whatever is in it, the class can access it without having to rewrite it. Plus, it can have its own function for us to use. That is how this inheritance works. So superclasses are also called as subclasses. Sorry, superclasses are also called as base class. The parent class is called superclass or base class. The child classes are called as subclasses or derived classes. Okay. Any question?
No.
Okay. So let's say this. Okay. For example, say we have a let's assume, okay, so we have this a car dealership now. Okay, we are going to write some program for the car dealership. Okay, so when you do that, how would you divide your program? We are not going to write a code, but we are going to show you what can be a superclass, what can be a subclass, and how every single item will look like, just so we understand the concept. Okay. See, OOPS is a big concept of its own. Okay, so the understanding of all these superclasses, subclasses, how do you derive, how do you inherit? It all comes by practice. The more you program, the more you get, the more you involve in the programming side of it, you will get to understand all of it. In theory, it will be as dry as can be. Okay, this would be the driest of all we have talked about. Okay, so, but understanding the logic, at least in like English terms, will help you. That's what I wanted. At the end of the day, I want you guys to just understand what it is. Okay, let's try for that. Okay, so now, like I said, let's take an example of dealership. Okay, so if we take a dealership in our area, then let's see what are the classes we can have, what subclasses we can have. Okay, so in the dealership, say they'll have he has cars, he has trucks, then he has SUVs. Okay, so then how would you define this? You will have a master class called vehicle. Correct. So under the vehicle, we'll have three subclasses because they're all vehicles, right? So car is a vehicle, truck is a vehicle, SUV is a vehicle. So this will be our superclass. Okay, and these classes will be subclasses because they have similar characteristics of vehicles, right? They'll have all the data points that I'm going to generically give in a vehicle will apply for them. So I don't have to rewrite every methods and every data as such, but there is some unique features that these cars and trucks and SUVs will have. Okay, so what is it? Let's say door. So everything is going to have door, right? But the car might have when you initialize cars, it will be like 2 door, this will be like 4 door, this will be like 5 door, whatever. Okay. Okay. So this will be for this. Okay. So how do you differentiate this? So on the superclass, what would you write generically? Like, so this superclass will have all the features that is common for everything. So make is common, model is common, mileage, and price. Okay. So let's say price. So these data attributes would be common for all common. We'll define that in the superclass. Okay. So this is the data attributes. So what methods can this superclass have is? Anyone?
I'm driving. Going. Oh, okay. The methods. Okay.
Methods. Okay. So you'll have a initialize method. You will have a set method, right? For all these variables, you will have a set method. So set method for a make, set for a model, set for mileage, and set for price. So whichever you want to set, you will call one of these methods to set these variables. Similarly, if you want to get, you do the same thing. You will have a getter, get everything will have a getter and setter, right? So you'll have a get for make, get for model, get for mileage, and get for price. So you get the values, you get it. Okay. So now if you go to subclass, so what additional thing this cars can have is, so this is going to have everything for vehicles. Okay. So when you create an object of car, this since we have called this as a subclass, all whatever it's defined here, it's applicable to cars too. Okay. Plus, what is extra is you can say doors, right? So cars have doors, like the doors of the car is different. They have like it can be a 2-door or a 4-door. Okay. That's an extra data for cars. Okay. And methods is similar, even though this is again a class, right? So it in itself should have an init method. Then you will have a get method and set method for this door. Get method and set method for door. Okay. So similarly, trucks. So what do you do for trucks? What is one extra characteristics you can call for truck is drive type, right? You can call if it is a 4-wheel drive or a 2-wheel drive. So that varies, right? So based on that, that is an extra characteristics of this vehicle. So that is my data. So then method will be similarly, it will have a getter and setter, right? So it will have a get drive type, and it will also have a set drive type. So you can use. Yep.
Is it compulsory to like specify the init method, or is it okay if it not do anything about it?
You have to. It is mandatory.
Okay.
Or if you don't do, what happens is like this drive type variable will not be initialized. You cannot use it. You can still use all this here, whatever you have it here, but you're not initializing this drive type here, right? So you will not be able to use this variable if you don't initialize.
Okay.
Yeah. So then for SUV, what is one extra thing for SUV? It has tire, it has everything the same. What is different in an SUV?
Trunk space.
Trunk space. Is it trunk space? Is that what I said? Trunk space?
Yeah.
Okay, trunk space. Passenger capacity, right? It can be like five seater, 6-seater, 7-seater, or 8-seater. So SUVs, right? So these are two characteristics we can have. So now method is going to be, you're going to have an init method, then you're going to have a get set and get. That's it. So when you design, so now when you have it, so these are all the classes and subclasses you're going to have in your program. Okay. So how do you tell when you derive, right? So we have seen this syntax, right? So when you define a class, you tell class vehicle, correct? So then you write whatever you want to write. So when you write a subclass, how do you do that? Is the superclass you define like anything else. So subclass, when you define, say, what is our first subclass here? Cars, right? So when you tell cars, so now you are telling cars is a class of vehicle. So what does this tell you is, it's telling cars is a subclass of this parent class vehicle. So that is the keyword class, subclass of superclass. Okay, so this is how you define it. So now when you read it, so you see all you can see is you see a cars of vehicle, right? So it means cars is derived from this superclass vehicle. So similarly, if you want to write for what is the next one? Trucks. It will be class trucks of vehicle. Then you write whatever you want to write. And similarly, we have what else? SUVs. is a subclass of vehicles. So this is how it defines. So whatever you write, all the unit and everything is the same, like the programming, how you have it here, right? This define method, this whole method, everything is the same, but this is how you differentiate a superclass from a subclass. Any questions?
No.
Okay. What we can do next? We saw about this. So the UML diagram that, so whatever we have I've shown you, right? So this is how you represent the UML diagram in case of inheritance. So in a class, you just have this. You represent every class like how you normally would do, but then this arrow tells you which is a subclass and which is a superclass. So here the arrow is pointing upwards, right? So what does that mean is this car, this truck, this SUV, all are derived from this automobile superclass. So this is how you represent the UML. You represent the inheritance using the UML diagrams. Okay. Okay. Next, what do I want to do? So okay, let me go. Let us see one example and then go to quiz. Okay. I think I have not shown you how the this get and set works, right? So first I'll show you an example of how this get and set works. Okay. So let's take an example of car. Okay. So we'll say we are going to have a class car, and what it's going to do is like it's going to have two methods. So one is brake, right? So other one is brake and what does it do? Accelerate. Okay, it's going to have accelerate. It's going to have two things. It has to accelerate. It has to brake. Okay. Then so we'll see how to do that. Okay. So you define your main class, which is car in our case, and I'm going to have the initialization method, right? The init method, and it's going to be self. Then what do I have? Like, what do I have? I'll have year. I'll have the make and the speed, right? I'll have these three parameters, and I want this year and model as user inputs. Okay, so I'm going to have the user enter me the year value, and I'm going to tell the make model of the year. Okay, make or model, whatever, make and model of the car. This I'm going to get it from the user, and speed for now I'm going to initialize it to 0. Okay, so whatever year I'm getting here, it's going to be here and make. So this all these values have to be what? Self dot, right? So the class car is going to have 3 data points: the year, the make, and the speed of the car. I'm initializing the speed of the value as 0 because I'm going to use this accelerate and brake method to change it. Okay, so for now I'm getting it as 0. Then I need method, right? Like I said, I need 2 methods. So whenever I call this accelerate, oops. So whenever I call the accelerate method, I want the speed to increase by 5. Let's keep it like that, okay? So this is again on self. So what is the speed there? Self dot. Okay. I said I want the speed. I'm gonna make it as private. Why? I'm gonna have this function change the speed for me, not directly from the outside. Okay. So in order for me to do that, I'm gonna make it as like double underscore. So this you cannot directly change. You cannot call self dot speed in your calling function. You cannot do that. So I'm gonna just make it private. So how do you change the speed? Is the only way to change it is accelerate. Okay. So what is the speed is? Top speed is equal to whatever the current speed is. Whatever the current speed is, I'm going to increase by 5. Okay. So every time you call this accelerate function, I'm going to increase the speed to 5. Okay. That's what I'm going to do. So the next one is the break function, right? So let me call the again a self. So now what I'm yep, go ahead.
Yes. So what is the self parameter there?
So self tells is like whichever object is calling for that the variable speed. Like you can create an instance, right? You can call C1, C2, C3, whichever you call. It's like C1 dot speed, C2 dot speed, C3 dot speed.
Oh, okay.
You are telling itself. So this variable is acting upon that object that is getting called.
Okay, thank you.
Here in our this example, right? So when I call P1, the self means P1 dot age, P1's first name, P1's last name, P1 age, P1 height. So this variables has to act on an object, correct? So in this case, P1. So whichever is calling that particular object's variables. Okay. So in this case, what I'm going to do is I'm going to subtract the speed to 5. That's it. You could either do like this or like this or the same. So I have now two functions or two methods. So one will increase the speed, one will decrease the speed. It will modify these variables accordingly. Okay. Then I need a getter, right? Because if you want to find out what the current speed is, I want the system to show, right? So I'm going to just have a getter. So get speed of self. So whenever you call it, it will tell you, it will give you this print current speed is dot speed. Okay, so my class is ready now. So now I'm going to have my main class. So first, what do you need? I need to call this class object, right? In order for me to create an object for this class, I need the year and make as a user input. So I'm going to get year is equal to input, enter year is manufactured, and make is equal to input, enter make of the car. So instead of hard coding, just getting the value from the user. Now I'm going to create an object. Okay, so let's call C1. So the object C1 is nothing but the object of a car. Now I need to pass what? Year and a make, right? So I'll just pass the year and make here. Okay, so now my object is created. So now I want to say if I want to find out what the current speed is, all I have to do is like g1 dot get, where is it? Get speed. Correct? If you want to increase the speed, what do you do? C1 dot
accelerate.
If you want to break it, then now if you want to find out what the speed is again, you just get your speed. So you can just repeat whatever you want to do. So Now, if you see, I did not. This speed is a variable, right? The speed is not. Speed is a actual variable, right? I have not exposed this variable anywhere in the program. Correct. No one knows what the variable is, how it is stored, nothing. It's not at all exposed. You want to increase it, increase it. You want to decrease it, decrease it. That's it. Okay. Even here, right, instead of doing it every time by 5, you could also have an argument passed and then you tell user how much what the number you have to pass. You can do it. But in either case, the speed is protected. It's not exposed at all. You use the getters or the setters to actually increase or decrease act upon these variables. Yeah. So now let's run this program.
You missed a call.
Thank you. Okay, it's not printing. Maybe I should have done this instead of having a print here. Maybe I should have done return. Let's try this. Okay, let's return the value here and then let's print it here. Okay, print current speed is no, something else is happening. What's happening? Oh no. Okay, both are correct. Anyone? What's the problem? What's happening?
Oh, we didn't define the main function.
We defined the main function.
We didn't call it.
We didn't call the main function. The program is not calling it out. So what even the earlier thing should work, like printing here should work. So enter year, it's 2019. Make, what is the make? Make. Please call. Make. There is an error. Car object has no attribute speed. I have used only a single underscore. So manufacturing 2020, make of the car is. So current speed is 0, right? So first time I called car, I just initialized it. So when you initialize the speed was 0, so the current speed is 0. Then we called the accelerate function. So accelerate, what happened is it increased the speed by 5. So after that, when I printed current speed, the current speed is 5. Now if I just call the break function, right? It's going to decrease the speed by 5, right? So once I have that and printed, now my value should be 0. Okay, so speed was 0. After accelerating, it was 5. Then again, when you call this function break, it's 0. So though they are all different functions, they're all acting on this one particular variable speed without exposing it to outside world. So this is the getters and setters. Any questions? Understood how it is?
Yes, but this one, how do you use the set and get function? Like instead of without writing using the print statement for get, is there like a keyword, for setters?
For setters?
Yeah.
Yeah, for setters, it's like you have to assign the values, right? So for print, getter is mostly what you just get that value, right? So without using the print statement saying like you want to store this, you want to store the speed, right? So speed, if you have a variable called speed, if you have a variable called current speed, c1 dot get speed of. Now this current speed will hold this value. Then you can do whatever you want to do with this variable. It's like a.
How could we do it for set?
Oh, you mean for setters? Okay. For setter is mostly the other way around, right? You allow the this is kind of a setter, but let's say. So define set speed of self, comma, speed what I'll just do. Okay. So now what it is doing is I'm telling it. So whatever the value I'm getting it, assign that value here. Okay, this is the setter. So this getter just returns the current value. Setter, what it does is it allows you to set the speed. Now, whatever this argument speed one is coming, that will be the variable for setter. Okay. So now here I just simply pass c1 dot what is it function set speed, right? I just call the set speed. I just call the set speed and then tell 15. Okay. So now after that, if you print, I'll just set it as 100. So that's a big difference. So for clear, so I've defined a function called set speed. That function gets a parameter speed one, and when I call that function, I am passing that value here. Okay. Again the colon. See, the current speed is 100. So whatever value you pass will go here. That's the setter. Setter is nothing but assigning the value to the variable.
Okay, thank you.
Okay. You could also do a setter for like like say you want to change it again. You could again ask the user to input. You could have the setter for every single object. You could also have a setter method for changing the name. Okay. So you can say set, what is it? Year was there, right? So set year, right? So what will this do is self.year is equal to here. So now when you call this function pass a year, this year value, like first time you initialize with something. Now whenever this user calls this function, you're letting him initialize it again. Okay. So that is the setters. So here you will just call c1 dot set year as 2089 something. So now the value will be changed to 2089. That's the setters. It's nothing but you are defining its own function to change the values and letting the user use that function to change the value instead of giving them the access to the whole variable as such. You could simply do it like c1 dot year equal to 28. You can do that too. Okay. So, but when you can make this year as private, and then when you make it as private, user cannot change it using this method. They will have to use this set method to change it. That's the difference. Instead of changing the variable, change it using the method. Clear? No? You there or gone? Okay. Hey, gone, Abhishek? Confused? Okay. Let's wait for it. It's on mute. Anyways, so anyone else? Any question? How the class is defined? How to use it? How the getters, setters? How do you use it? Okay, I assume everyone understood. Okay, thank you. Okay, let's look into the quiz quickly and then we'll talk. Okay, so ready for the quiz answers? So the first question, a file that data is returned to is known as input, output, sequential, or binary file.
Output file.
Output file. Okay. Before a file can be used by a program, it must be
Opened.
opened. Option D. Question number 3. The contents of this type of file can be viewed in an editor such as Notepad.
Text.
Text file. 3. Option A. When working with this type of file, you access its data from the beginning of the file to the end of the file. Which one?
Sequential.
Sequential. Correct. When working with this type of file, you can jump directly to any piece of data in the file without reading the data that comes before it.
Random access.
Correct. Direct or random access. Option C. This is a small holding section in a memory that many systems write data to before writing the data to a file.
Buffer.
Buffer. Option A is correct. Question number 7. When a file is opened in this mode, data will be written at the end of the file's existing contents.
Append mode.
Append. Correct. When an input file is opened, its read position is initially set to the first item in the file. True or false?
True.
True. When you open a file, that file already exists on the disk using the W mode, the contents of the existing file will be erased.
True.
True or false?
True.
True, correct. It will just erase and rewrite it. The process of opening file is only necessary with input file. Output files are automatically opened when data is written to them.
It's false, I think.
False. So whether you write or read, you have to open the file and you have to close the file. Good job. So let me see here. Okay. So we have Sanvi, Abhishai, Rohan, Elzik, Likita, and Eddie. So who have scored 100 marks in today's quiz. Congratulations, guys. It's Sanvi, Abhishai, Rohan, Elric, Likita, and Eddie. I hope I got your names correct. But good job, guys. All right. So that finishes the quiz. So the next one we have is, or what is next? Next is homework, right? So any questions before we go to homework on classes, today's class, or any other class? Okay, I take it as a no. And for homework, the good news is, or the bad news is, it depends on what you take. You don't have any homework as such for this week, because I know next time when we are going to meet in 2 weeks, it's going to be your final exams. So there will be no homework as such for today's session. But please go through the lecture notes, and these PPT will be published in a bit. So please go through them and try to understand and practice the class concepts so you get familiarized, okay? So having said that, so we will also publish kind of a study guide kind of thing, like with all the quiz questions that we have so far, plus something extra, and post it on your class material. So you could use that as reference while you're studying. So next week will be your final exam. So study for it and let me know if you have any questions, okay? You could message me on that message center if you need any, if you're not clear or if you need any understanding on that.
Oh, wait, is the final exam just like a multiple choice questions, or
Yes,
do we have to
yes.
code some stuff?
It will be a multiple choice questions.
Okay.
You'll not be coding, but there will be evaluations like we will give you a set of code and we will say this is the output, and we would give you just the code and we would want you to find out what the output is, kind of thing. But the answer is always going to be multiple choice.
Oh, okay.
Clear? So I'll just ask you 2 plus 3 is what? Something similar, okay? With the programs too. It's not just going to be like just text multiple choice, but you will see some programs in there. So study and all the best, guys. So hope you guys prepare for it well. And like I said, if you have any questions, reach out to me. That's it. Anything else from anyone?
No.
Okay. If that is all then. That's for today. And we'll see you guys in 2 weeks. And have a good rest of the weekend. Enjoy. And good luck for your final exams. Study and
Thank
be
you.
the best. Thank you. Bye bye, guys.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!